My name is Marcin Sudlis. I am a PhD student in the Institute of Nuclear Chemistry and Technology, and I would like to present our patent application, a method of biogas production, in particular from excess sludge in municipal sewage treatment plant or from a mixture of substrates containing sludge. Secondary excess sludge is a waste which is obtained in wastewater purification process. Wastewater entering wastewater treatment plant is firstly filtered to remove grit and sand, then directed to settler. Primarily purified water is then pumped into aerobic digester where naturally occurring processes are accelerated in controlled conditions to remove most of the soluble organics. This is where secondary sludge is taken from. Sedimentation process allows to separate purified liquid phase from formed flocks. Sewage sludges are now quite urgent problem. In Poland in 2019, over 1,048 tons of dry mess were produced. Huge amounts of dewatered sewage sludge must be stored in wastewater treatment plant area due to ban of sewage sludge storage in landfill. An option is utilizing as fertilizer, but this is taking a risk of soil contamination with parasite eggs present in municipal wastewater. Another possible way to use is production of biogas in anaerobic digestion process. Anaerobic digestion or methane fermentation is a multi-step biological process where different microorganisms living in symbiosis transform biomass into methane and carbon dioxide. In the first step, hydrolysis, large molecule compounds like lipids, carbohydrates and proteins are decomposed into simple compounds like alcohols, fatty acids, monosaccharides and some gaseous products, hydrogen and carbon dioxide. Acetogenesis produces volatile fatty acids which are in acetogenic phase digested into acetic acid, a main compound to produce methane and carbon dioxide in methanogenesis. Also some methane is produced from hydrogen and carbon dioxide. Methane can be compressed or burned to produce energy. Usually plants or agricultural waste are utilized as a biomass for anaerobic digestion. But secondary sludge as a biomass full of nutrients can also be successfully used as a substrate for methane fermentation. Sewage sludge has form of flocks suspended in liquid phase. To accelerate process of methane fermentation, disintegration of substrate can be performed by delivering of some form of energy to destroy flocks structure. That releases more nutrients into water phase, making them more available for microorganisms, thus making the whole process faster. One of the ways to deliver energy is irradiation. In water environment, water radiolysis occurs, leading to formation of water radiolysis products including highly oxidative hydroxyl radicals, highly reductive solvated electrons and hydrogen radicals. Chemical interaction of water radiolysis products with compounds present in sludge cause their decomposition into soluble substances and flux damage. A laboratory-scale experiments were carried out to observe effect of irradiation of sewage sludge on anaerobic digestion process characteristics. Process was performed in mesophilic conditions, 38 Celsius degrees, using 80% of secondary sludge and 20% digestrates from biogas plant as inoculum. Audiometric sets according to TIN 38414/8 norm connected to 400 ml reactors were used to measure biogas volume. To measure soluble chemical oxygen demand reflecting concentration of nutrients in water phase, photometric tests were used. Non-irradiated and irradiated to 3 kg dose samples were used for the experiment. Tests shown that for the first period of process, volume of biogas obtained from irradiated samples was significantly higher in comparison to biogas yield obtained from non-irradiated sludge sample. Also measurements of chemical oxygen demand parameters in water phase reflecting amount of soluble organics shown increase of nutrients concentration in liquid phase after the irradiation. That phenomenon can be used in practice to build biogas plant connected to electron accelerator. Sludge would be directed to the irradiation facility, then to anaerobic digester. Obtained biogas would be used in cogeneration process to produce heat and electricity, while biologically safe digestate would be used as a fertilizer. And two possible ways can be chosen. One is to get same amount of biogas in shorter period of time in comparison to process without electron beam treatment performed in the same digester size. Second is to get same amount of biogas in the same period of time, like in the process with no electron beam but with smaller digester.